Hey guys, maybe you're sitting in the comfort of your own home with the snow falling down. But anyway, you still got to do some math. So we're going to do the product rule. So we've been talking about derivatives, and we're going to continue with derivatives. But basically what's going to happen is we're going to get a derivative where it's going to look something like this. Now remember, product means to multiply. So basically what you have here is you have two binomials that are being multiplied. Now, we could double distribute this and then take the derivative, kind of the way that we've been doing the past couple of days in class, or we can do something called the product rule. All right, so basically what the product rule is this. I'm going to show you how to do it first, and then I'll write down the real rule for it. So the product rule states that when we want to take the derivative of something, where we have two products, we are going to take the first term, which is x squared plus 1, and we're going to multiply it by the derivative of the second term. And the derivative of the second term is 3x squared. Then we're going to add, and we're going to take the second term, write it down, and then we're going to take the derivative of the first term, which is 2x. And that's the product rule. So the product rule, let's just kind of repeat again. You take the first term, and then you multiply it by the derivative of the second. Then you take the second term, and you multiply it by the derivative of the first. Okay, so each term gets a turn to be derivatived, so to speak, and each term gets a turn to just stay the same. So now all you're going to do is do your distribution here, and we're going to have an answer. So if we take these first two sets of parentheses, we'll get 3x to the fourth, and then we'll get plus 3x squared. Okay, and then with the second set over there on the far right, you're going to get plus 2x cubed. Oops, I'm sorry, 2x. Let's see if we can erase that because that looks a little messy. All right, so let's go back. All right, so that would be 2x to the fourth, my mistake, and then plus 6x. Okay, and then what you're going to do is you're going to look at your answer and you're going to say, ooh, we have like terms. So you're going to add the like terms, 5x to the fourth, that's a 4, plus 3x squared, plus 6x. Okay, and that is your answer to the problem. All right? Okay, so basically what we did was, and I'm going to look at another example of product rule, and then I'll give you the official rule. So let's say we have x squared plus 2, and we're going to multiply that by x to the fifth plus 1. Okay, and we want to do product rule. All right, so we call this whole term here u. It's an expression. And then this whole term here, v. So this is the definition of product rule. The product rule states that you keep u, and then you take the derivative of v. Then you add, kind of like when you did logs. Remember all the log rules when you had products you added? Same deal, okay? And then you take v, and then you take the derivative of u. So this here is the official definition of product rule. Okay, so let's just do it. So we're going to take that problem all the way up at the top there, and we're going to do x squared plus 2. We're going to multiply it by 5x to the fourth, then plus x to the fifth plus 1, and we're going to multiply that by 2. Oops, come on, pen. 2x. There we go. So now we're just going to distribute, and we'll get 5x to the sixth plus 10x to the fourth plus 2x to the sixth plus 2x. Then all you need to do is combine your like terms, 7x to the sixth plus 10x to the fourth plus 2x. And there we go. See? And you didn't get to miss looking at the snow. It's only a couple of minutes. All right, so now what you're going to do is I gave you a worksheet. I'd like you to work on that. It does have some product rule in there, and then it also has some review of basic derivatives and tangent lines and whatnot. So have fun doing that, and hopefully I will see you tomorrow. Bye.